Okay, we're back in the second part of this video where I'm going to complete. I've got example 4 and then also example 5 to complete. So we're C equals 1 in our trace table. When C equals 1, we're modifying list at location C, list at location 1, this one right here, and it's going to be set to the most recent value of count, which is 2 minus 1. 2 minus 1 is 1. So that the 1 goes there. Now, count has to be updated at the end. So notice it follows a linear sequence. It does line by line, and I think everybody already knows that, but it's really important to be aware of that when we're doing this. Okay, count equals count plus 2. The previous value of count was 2, so now it's going to be 4. That's now the most recent value of count. And notice it got changed after the value of list got updated. Nothing else gets changed in this iteration of the for loop. So for this particular row, and I should mention this is probably obvious, but I'm going to state it anyway. Each row in the trace table represents one iteration of the for loop. And you can see that clearly with the value of C. C equals 0, C equals 1. So none of these got changed, so we're just going to carry through what the values were. And now we go back around again. This is probably the hardest example, I think. But you will be getting one example using a list. And just keep in mind that a list is just a collection of variables all the same type, and they're represented, they're accessed with indices. So this is index 0, index 1, index 2, index 3. So index 0, index 1, index 2, index 3, just as a review. Okay, C is now 2. We loop back around. And C is the independent variable. I'm going to put all the values of C down just so you know how far we're going here and when this thing's going to be over. So when C is 4, it's going to execute the body of the loop. When it becomes 5, it exits right away. So we don't have to put 5. We can stop here. So we got to do this 3 more times. So when list is 2, when C is 2, we're going to be modifying list at location 2, and that's going to be equal to the most recent value of count, 4 minus 1, so 3. And the value of count changes by 2, so now it's 6, and everything else stays the same. This might help you understand things. If I circle all the values that change, so that value changed in that row, that value changed in that row, that value changed in that row, everything else stayed the same. See, it didn't change after that, just for the list. I'm only doing that for the list. Okay, so now when C is equal to 3, we're going to be modifying list at location 3. And list at location 3 is going to be equal to the most recent value count minus 1. So 6 minus 1 is 5. And now count becomes 8. And everything else stays the same. So negative 1, 1, 3. All right, now let's see what happens. C is 4. We're going to try to modify list at location 4. And it looks like we're going to get a syntax error. So you just put error, because it's trying to access list at location 4. List at location 4 doesn't exist. See that? So there's an error, and that's how it ends. You may or may not get an error with the exercises, but if you do get one, if you do get a situation like that, you just put error or something like that. You don't have to do anything else. So one last example, example number 5. And example number 5 is shorter. So let me just see if you can see my camera okay. So 5. So we have x equals 0, y equals 15, and then we have while x does not equal y. So remember, that's the not equal to symbol. We're going to do x equals x plus 1 and y equals y minus 2. So in this program, kind of an interesting program here, x starts, think of the number line. It's just kind of an aside. So we've got 0 and we've got 15 here. So x starts over here at 0 and y starts at 15. X is increasing by 1 each time, and y is decreasing by 2 each time. So you can see they're going to either intersect or hop over one another. If they do intersect, the while loop will end. If they don't intersect, something else will happen. So let's do the trace table. We've only got two variables. We've got x and we've got y. So x starts off at 0 and y starts off at 15. That's before the while loop starts. And so now the while loop starts, and well, it says it's going to loop while x is not equal to y. Is x equal to y? No, so we're okay. We can continue continue this while loop or start it. So x is going to be increased by 1, so it'll become 1. Y will be decreased by 2. And then it loops around. It checks. While x is not equal to y, continue doing this loop. And they're not equal, so we're good. So x is now 2, y is now 11. And we continue this process, each time checking to make sure that the values are not the same. 5, 7, 6, 5, and there we go. So now, when it gets to this step, while x is not equal to y, well, x is equal to y, so we end. That's the end of the loop. All right, so that's now if they never became equal to each other, it would be possible if y hopped over x and then this loop would never end. But that would not be a question that I would want to give you, or I'd say just do the first 5 rows. Okay, so that's it for trace tables. Believe me, trace tables are going to help you become a better programmer at the stage that grade 11s are in, especially with the limited experience that we've had because of this particular semester in the quarantine. This is really going to help you out. This is really the meat and potatoes. It's going to help you become a better programmer. And I know we only have a couple of weeks left, but you're going to be able to be exposed to this. I will have the worksheet will be something that I'll ask you to hand in. Bye for now. Do the worksheet. If you have any questions, feel free to email me. Remember, I have those live office hours on Tuesday as well. Okay, take care.